Good morning. I'm happy to be here. As the title goes, I'm here to talk about three things. First is about celebrating 10 years of SNPP. The idea here is not to regurgitate potted history of SNPP and why we are here and how we got here, but think about it as a high school graduation party for your kid where you show old photographs and dwell upon the success of the past decade or so. Then I'm going to talk about the current status of JPSS, just like Andy did for the GOSAR mission, and also talk about the new mission or the new program that we have, which is the LEO program. Here is the background for SNPP. SNPP was a risk reduction pathfinder for the current JPSS program. In 2021, we marked 10 years of successful operations of SNPP. It is a NOAA NASA program. It has a whole new set of payloads that we are not used to seeing when SNPP was launched. CRIS is the first hyperspectral infrared sounder in LEO, the first microsecond interferometer to fly in the afternoon orbit on a NOAA satellite. ATMS has the same channel set or very similar channel set as the legacy AMSU that we have still flying on the post satellites. The A in ATMS is the advanced technology microwave sounder. We recently did a study on what the current technology of a microwave sounder would look like at the NASA Instrument Design Lab. And they concluded that the packaging of ATMS, after all these years, after more than a decade of flying, and more than a decade ago it was developed and built, it is still a very compact design. VIIRS is based on the MODIS heritage, but it has some new features, or has some features that overcame some of the shortcomings of MODIS, like the bow tie effect is eliminated. And ARMS fulfills the US treaty obligations to monitor global ozone concentration and ensures that there are no gaps in the heritage terms and SBUV. Currently, all SNPP sensors are operating nominally except CRIS that suffered an anomaly last year. And CRIS is operating on SNPP only with shortwave and longwave radiances only. Thanks to Mitch Goldberg, we have a healthy science program and a science budget for JPSS that I inherited. And a part of the science budget and science program is to enable CSPP development. And a lot of people in this room contributed and continue to contribute to the success of SNPP. And also for a CSPP development, maintenance, as well as enhancements. We have an annual digest, and the 2021 annual digest highlights all the accomplishments of 10 years of SNPP. There are 4 areas within the science program. One is Proving Ground. Proving Ground is the concept where we take existing products and demonstrate within a user business framework so that they can exploit the data to its fullest extent. Then there's risk reduction, where we are looking at new algorithms. Then there's innovation, which looks at improvements and opportunities beyond the original mission objectives. And finally, the most important thing, in my view, is training users to effectively use the data sets from the mission. The hexagons that you see here are the different areas of focus of the Proving Ground Risk Reduction project. Here is the timeline of different milestones for SNPP. The major takeaway from this is it took almost 2 years for VIIRS and ATMS to be operationally used by the Weather Service. It took almost 3 years for CRIS to be operationally assimilated into NWP. And it took 4 years for the retrievals from new caps to show up in AVIPs. Based on the experience that we learned from SNPP, the timeline for NOAA 20 to put things into operations was much shorter. We were able to push NOAA 20 radiances into weather surveys, and they were able to assimilate it in less than a year compared to what it took 2 to 3 years on SNPP. Here is the impact of what the JPSS and other polar satellites on NWP. This is the forecast sensitivity observation impact analysis that I downloaded from the NASA GMAO yesterday. The top two most impactful sensors continue to be SNPP ATMS, followed by NOAA 20 ATMS, even though they are in the same orbit, separated by 55 minutes. I would also like you to look at the impact of the legacy post satellites on it, which I'll talk about a few minutes later. The NOAA 15, 18, 19 AMSUs continue to provide good, useful data, and they continue to have a high impact on NWP. Due to this reason, we have been directed by Congress to extend the legacy post satellites by a few more years. This is also something the NWP community wanted. They lobbied for it quite hard. And we are going to extend the legacy post satellites. The legacy post satellites are like zombie satellites. They refuse to die. They continue to provide good data. Even though they were launched in the early morning orbit, they drifted over time, and they're conveniently spaced now where we can get 3 to 4 hours microwave sounding refresh globally. Even though ATMS is a sounder, we do generate imagery from it. The image on the right is the 88 gigahertz brightness temperature of Hurricane Laura. The 88 gigahertz imagery is also called the poor man's radar imagery by the forecasters because it provides useful imagery data like you see here. It's very useful for delineating the Hurricane IOL, for example, in areas especially offshore where there is no conventional radar coverage. Talking about the impact of latency and the importance of timeliness of data. Here is a recent paper published by Tony McNally at ECMWF, where he discusses the impact and the usefulness of the most recent data before the assimilation window closes. So if you look at a 24-hour assimilation time cycle broken up into two assimilation at 12Z and 24Z, the latest, most recent data set just before the assimilation window cutoff has the highest impact on the NWP models. This shows the importance of direct broadcast, low latency data for NWP from all the observations. In preparation for future measurements from LEO, NESDIS office of OSAP has a team called the Science Advisory Team. Many of you are members of it. This is led by Dr. Sid Bukabara. We looked at what should be the latency for different measurements that feed global NWP. And these are mission agnostic measurements. This has a list of measurements that are currently used, including air temperature profiles, water vapor profiles, sea ice concentration, sea surface temperature, wind speed profiles, and things like that. And if you look at the latency, less than half hour is the latency that would have the most impactful observations assimilated into the NWP. 1 hour is something that we can do now, and if the latency is 6 hours or more, the data is of very little value. Here are some highlights from SNPP. Here is a animation taken on 26th August 2020. The purpose of this image is to show how the different sensor data are used together. You can see Hurricane Laura churning in the Atlantic. You can see fires burning in California. The haze, the purple haze, the bluish haze, is the smoke and emissions from the fire that got advected all the way to the East Coast. The VIIRS fire radiative power, the infrared band, saturate at very high temperatures. So far, we have not seen any saturation in the infrared temperatures. When we looked at the temperatures of fires in Australia 2 years back, they are a critical component of the HERS smoke model that OER developed, which is operationally used. You can see how the fire radiative power feeds the HERS smoke model. That is the animation on the right. And the animation at the bottom is the three-dimensional view of Hurricane Laura from ATMS. You can see the different profiles of brightness, temperature, on the x-axis, y-axis, and the z-axis. If somehow we could take Hurricane Laura and move it to the East Coast, we would have put out the fires there. Here is another cool animation. Last year, an iceberg broke off from Antarctica. This is the iceberg A68. It broke off near the Isles of South Georgia, and you can see in this animation the iceberg floating in the Atlantic until the time it finally breaks off. This is a 6-month animation of VIIRS. I have to come up with the animations to compete with my brother who gave the talk with ABI, which makes these movie loops every 5 minutes and 1 minute. Right? So it's almost a hard act to follow. The other unique feature of VIIRS is the day-night band. A lot of the features that the GeoXO wants to put in the geostationary orbit, these capabilities have been demonstrated and proven in the LEO orbit, and they are making their way into the geostationary orbit in the next decade. You can see this is the animation by Sierra. This is the day-night band. Sierra, Steve Miller did some very amazing innovative uses of the day-night band. You can see the aurora borealis over the North Pole in this animation. We also have some rudimentary capabilities of ocean color on VIIRS. And it is the first ocean color sensor that NOAA has to take care of the needs of the fisheries and ocean service. Here's an animation of ocean color over a period of 1 year from VIIRS. Here are a couple of animations. What you're seeing on the top is the multi-sensor retrieval of temperature and water vapor profiles. This is the NewCaps retrievals. It is a part of the SNPP package. NewCaps retrievals from NOAA 20 are in AVIPS. Forecasters use it for nowcasting. And what you're seeing in this image here, these waves are the O-B observations caused by the Hangatanga eruption. You can see the impact of these atmospheric ripples going across the globe. And NewCaps also retrieves trace gases, including CO and SO2. What you're seeing here is carbon monoxide mixing ratios from the Australian fires in 2020. And last but not least, here are the capabilities of ARMS, which is a very important sensor for monitoring the ozone hole or the poles. And it also has the capability to measure sulfur dioxide, and the animation what you're seeing at the bottom is the SO2 from ARMS on SNPP from the Hangatanga eruption. After a decade of SNPP, it's time to reprocess the data. Why do we need to reprocess? There are several improvements that took place over the life of the SNPP mission, especially for the sensor data records. These include updates to calibration, stray light correction, terrain correction, non-linearity, and updates to geolocation corrections. All of these things have been applied to the data sets for all CRIS, ATMS, years, and ARMS. The reprocessed data set is now available at class. One of the things that I want to highlight is historically, if you look at the requirements for all of our POST missions and those missions, monitoring climate is not a requirement. But these sensors historically have been built to such high exactings and high standards. They provide data that is of very high quality. It is considered as the standard for climate studies. So this reprocessing enables us to build the long-term data records for climate going back to, for example, 1980s, from the legacy POST satellites to the present time period. This data set is available for download on class. Now talking about where we are now, as I mentioned, we finished 10 years of operation in SNPP. NOAA 20 is the prime satellite, and SNPP is the secondary satellite. Both sensors are operating nominally. The image you're seeing on the right is the JPSS2 on the turntable. I'm happy to announce that JPSS2 successfully completed its TVAC. The pre-ship review is scheduled for the first week of August. On 24th, it will be shipped to Vandenberg. It will arrive in Vandenberg. It will move to the launch pad on October 17th. And launch is currently scheduled on November 1st, or early hours of November 1st, the night of October 31st from Vandenberg. Here are some other pictures showing the full deployment of how NOAA 20 would look like after the solar panels are fully deployed. This is a very spectacular pair of images that's showing how big the sensor is. Here is the flyout chart of SNPP, NOAA 20, followed by JPSS2, 3, and 4. We expect the program to continue providing valuable data till the end of the next decade. I was interviewed by NASA TV recently for preparation for the JPSS2 launch. And the interviewer asked me one question which I had to pause and think. He wanted to know, is there anything that I would like to share with the viewers about the program that we haven't thought before? What I told the interviewer was, if you look at the timeline from the beginning of the program till end of the mission, sometime end of the next decade, and maybe beyond that, it is a multi-generational mission. When I say multi-generation mission, there are a lot of people who worked on the mission before me. Some people like Bruce Gunter, who contributed significantly, have passed away. Some retired. We are here. We are going to launch J2. We are going to launch J3. And there will be a new generation of scientists who will continue to use this data well into the next decade and beyond. So these are truly multi-generational missions that see through 2 to 3 generations of scientists and engineers, which is a very important, significant, and an amazing fact. I would also like to highlight our partner missions. Equine talked about it yesterday, so I'll just briefly mention this. We are looking forward to EUMETSAT launching the METOP SG, or EPS second generation A and B satellite. These are very unique satellites with payloads and sensors that we have never seen before, like TMI, the microwave imager, the ice and cloud imager, the scatterometer. All these sensors, all the measurements are new. ERZ NG is ERZ on steroid. It has twice the number of channels, and we really look forward to receiving data and exploiting within our user communities at NESDIS. It is a part of the Joint Polar System Program that is an agreement between NOAA and EUMETSAT. Per this agreement, we launched the afternoon satellites, and EUMETSAT maintains the mid-morning 9:30 orbit. Now talking about the future, the next generation of programs that we have at NESDIS. These are the 6 strategic objectives that we have in NESDIS. The first one is geostationary satellite. The second one is advancing space weather. The third one is US, which is LEO, evolving LEO architecture. Number 4 is what we call as common ground, which is a common agile ground system to process data from multi-missions. Number 5 is user engagement. Kat Hawley will talk about it. And number 6 is a product and services where the groups of scientists and engineers, of which you're all part of, will continue to provide the best product and services to enable mission success. Within LEO, we have 3 sub-objectives. One is to maintain the backbone. JPSS is the backbone. Number 2 is exploitation of partner data, as well also for institutional purchase. Commercial auto is one example. The third one is innovation. I'll talk about the third component. In 2022, we have been authorized to establish the Office of LEO. The LEO program is a loosely coupled program. One of the facets of this is to look at a partially disaggregated architecture. What does a partially disaggregated architecture mean? If you remember the picture that I have shown you of NOAA 20 fully deployed, it is a gigantic spacecraft. It has many sensors on it. And it takes time to procure these sensors, to integrate them into this spacecraft, and launch. If there is a delay in any one of the sensors, then the whole mission gets delayed. In a loosely disaggregated architecture, the idea is to launch sensors on smaller satellites that gives us the agility and ability to launch whatever sensor that we want in whatever orbit whenever we want it. So the first LEO satellite that we are going to launch is what is called the Quick Sounder mission. Our Quick Sounder mission is a ATMS mission. We have a ATMS EDU, Engineering Demonstration Unit, that has been tested many times. It went through many cycles of TVAC. We want to explore the option of taking that ATMS, putting it on a commercial small satellite, launching it on a commercial spacecraft. We are looking at options of somebody operating these satellite and giving us the data, which is all new to us. The LEO program strives to look at and address, thank you, the requirements that are defined in the NESDIS level requirements. We have a document called NLR that defines a set of products in atmosphere, cryosphere, land, oceans, and space. The LEO program makes measurements in every type of, in every region of the electromagnetic spectrum to satisfy the needs of the NOAA level requirements. We have multipurpose imagery, which is VIRS, which is Vis Near IR imagery. We have UV imagery, ARMS is an example. We have soundings from infrared, microwave, and radio occultation. CRIS, ATMS are part of this. Cosmic is part of this measurement suite. We exploit radar data from commercial data buys or from our partner missions. We have altimeters, microwave imagery, scatterometers, LiDARs. Every measurement is fair game in LEO. LEO measurement activities within NOAA are as follows. So we define the LEO as 3 types of missions. One that we manage from cradle to grave. JPSS is an example of a managed mission. Then we have partnership missions, EUMETSAT, EPS second generation, METOP is a good partnership example. Then there are leverage missions. Sentinels are a good example where the data comes to us for free and we use it to exploit the data. We rely on several partnership missions. I already talked about METOP. We also depend on JAXA for GCOM. And we have DMSP that is operated by DoD. Unlike GEO, LEO is global. And we expect and hope that a disaggregated architecture will provide the flexibility and agility to launch a variety of sensors. These are the different stages of the formulation. We are looking at what the users need, definition of sensors, followed by different studies. An important part of this activity is to work with users. We have 3 workshops. One was on microwave soundings, one was on IR soundings, the other one was organized by OER. They looked at the user needs for atmospheric chemistry from LEO. And then there is a VIRS workshop on 29th and 30th. Hope you can participate in that. We held broad agency announcement studies. We awarded contracts to see what the industry can offer for microwave and IR soundings. We got 3 types of sensors the industry proposed. There are high-performance sensors like CRIS and ATMS. There is mid-level sensors that have less capabilities. And there are low-performing sensors that only have a limited set of frequency channels. The higher the performance is, the more expensive it gets. And I already talked about the quick sounder mission, which is to launch an ATMS. And so here are some of the questions that we would like you to help us with. What is an ideal constellation? What is a LEO-GEO constellation look like in future? How frequently do these observations need to be made? At what point do you see diminishing results? Talking about quality and quantity, are more frequent, limited set of spectral observations better than less frequent observations? What is an ideal approach for conducting value assessments, which we all have to do? And how is the commercial market evolving? And what are our future opportunities? So here is the summary. NOAA 20 is the primary satellite. SNPP and NOAA 20 are operating nominally. JPSS2 is scheduled on November 1st. And we are putting together a special issue of remote sensing on VIRS. I hope we can contribute to it. And finally, I'd like to acknowledge the hundreds of engineers and scientists who worked on the success of the mission for the past decade and continue to do so for the success of the program in future as well. Thank you.
Any questions for Satya?
I said it. Based on what you know now, the weather system follow-on, is it going to be part of the NOAA constellation that the DoD is going to launch in the next couple of years?
Yes.
Thank you. Congratulations that you carried very successful programs in terms of missions, capability, and science for all years. So my question is directly related to CSNP role. So I wrote it down because it's kind of cumbersome sentence I want to ask. I want to make sure I don't shortchange it. So, as the JPSS program scientist, you have very special issues and important role to play. Okay? What do you see CSPP fall into your each part of the program in the size of mission component? Or it's more of a cross-cutting, it's not either science or the mission element?
It's a very good question. Thanks to everybody in this room and my predecessor Mitch. SNPP NOAA 20, I think, is in a very good shape. We got more than what we expected during the past decade. As we formulate LEO, my objective is to bring in additional LEO observations, especially our partner missions like a top second generation into the fold of LEO, where we need to exploit not just JPSS missions, but partner missions as well. And there are plenty of opportunities to do LEO geo science. That is, we are just beginning to scratch at the surface of those things.
Each used to tell me, just do as much as you can. I give you as much, I expect you 2 or 3 or 3 times more if you always do that. So I had to tell you that we try our best, but we always under the constraints of budgetary support that we wish to do.
Yeah, let's focus on the budget for a minute. We are, like I talked about, the 6 strategic areas of NESDIS. And he talked about GeoXO. They are going to formulate and design a whole new gaggle of sensors that we have never flown on Geo. So they are looking for a big budget. We are looking for budget to launch the next generation of satellites. We haven't even discussed space weather in this meeting so far. They are looking at launching a variety of new sensors in space weather. And we are looking at a budget cap constrained flat line in future, fitting all these aspirational measurements. That is a word that is going around these days, aspirational measurements and needs, is going to be a challenge. How do we fit all this in one suitcase or many small suitcases? We need to see that as the reality sets in as to how much these things really cost in future and what is doable. And we talked about the disaggregated architecture. It is supposed to provide agility and flexibility. We are looking at launching sensors every 2 to 3 years. That's not going to be cheap. It's not going to be any cheaper than what we are doing now. So it's going to be a challenge.
So as you participating in this conference, the meetings you see the users travel around the globe to come to here, hungry for more support, hungry for more capability, and we have limited teams who want to support it all. So please see a role of CSPP that you can continue to advocate for more so that we can continue the legacy since 1980 that is greatly amplified NOAA's mission in broad and optimal use. But I think those 2 words that you use all very often. So I just want to kind of urge you that you see our needs firsthand. Hopefully, you will go a long way for your planning of your program and continue to be successful for many years come, 2, 3, 4, multi-generation. Thank you so much.
Definitely, look forward to it. Thank you very much.
Any other questions? I've got a quick one.
Yeah.
Should be an easy one. What are NOAA's plans for SNPP after J2 becomes operational?
The current plan, so right now SNPP is secondary, NOAA 20 is primary. The plan right now is after J2 is checked out and products are validated, it would become the primary, NOAA 20 would become the secondary, and SNPP would become the tertiary. The ground segment, as designed, can only handle 2 strings of EDRs right now. We will continue to collect the data. The direct broadcast will continue from SNPP without interruption. Folks in this room who have CSPP and direct broadcast antennas can receive SNPP data and produce products. We will continue to provide the raw data records and all the raw data and the science data will be archived.
Excellent. That's good to hear.
Thank you.